All right, guys, today we're going to talk about probability, which is the basis for all insurance, okay? And we're going to start with a quote from Sir Arthur Conan Doyle, who was the one who wrote Sherlock Holmes. It is a capital offense to theorize before one has data. Okay, so all of insurance is based on risk, and all risk is calculated using probability and statistics. Okay, so there's a job called an actuary. It's a mathematician that uses probability to predict how often customers will make claims based on their classification. This is the guy who sits down, looks at a whole bunch of data, and says the probability of you, if you're a 16-year-old male, of having a car accident is going to be this, and the average cost is going to be this, and so this is what we need to charge for that policy to make sure that the insurance company makes a profit. It's a job that requires a lot of math, a lot of probability and statistics, and it has one of the highest job satisfaction rates of any job in the world. Very high starting salaries. These guys make a lot of money, and they work a pretty nice job. I have one student who is an actuary from about 8 or 9 years ago. Okay. Example number 1. A pail contains 7 red, 6 green, 3 orange, and 4 black marbles. 1 marble is drawn at random from the bag. What is the probability it is red? So what we need to do first is we need to figure out how many red marbles there are, which we know. Okay, there are 7 red marbles. And we also need to know how many total marbles there are. All right, so the total marbles is 7 plus 6 plus 3 plus 4. That's 20 marbles. So the probability of getting a red one is 7 out of 20, which if you want a decimal, you can divide that. That's 0.35, okay, or 35%. The other ones that use probability and statistics to their advantage are casinos. Okay, they know how much money is going to get paid out on a regular basis every day. They know how much money is going to come in. They know how much money is going to go out. That's the only way they can make a profit. And there's all the games in Vegas are rigged against you, except for 2. There are 2 games that you can turn against the house and have an advantage on the house. That's blackjack and craps. The rest of them, you're going to lose more money than you're going to make every time. The worst one of all is roulette, which I always thought would be an exciting game to play. The one time that I played it, it was super boring. And you're guaranteed to lose money over time anyway, so don't bother. Okay. Next, Logan picks a black marble from the pail and doesn't replace it. Brett will then randomly select a marble. What is the probability Brett picks a green marble? Okay, well, we've changed things now. Because we've taken out a black marble, there's now only 19 marbles. Okay? So, now there's 6 green marbles, so the probability is 6 out of 19 of getting a green one, which 6 divided by 19 comes out to be 0.3158 or 31.58% chance of getting a green marble in those conditions. All right, let's move on. A driver's ed class at Milwaukee High School has 23 girls and 20 boys in it. If one person is selected at random to represent the school at driver's safety exposition, what is the probability the person selected will be a girl? Well, there are 23 girls out of a total of 43 people. So that's the probability, 23 out of 43, that a girl will be selected. So 23 divided by 43, that's 0.5349, or 53.49%. A factory is planning to rearrange the parking spaces in its parking lot to better serve the employees. The employees work 3 different shifts and drive 5 different types of vehicles as shown by the table. So here we have 2-door sedans, okay, 4-door sedans, SUVs, pickups, motorcycles, total. Morning shift, day shift, night shift, total. Okay. If an employee is selected at random, what is the probability that that employee will drive an SUV? Okay, so we have to figure out how many employees drive an SUV out of the total number of employees. Okay, so if we get a total here, the total number of SUV drivers is 91. The total number of employees is 246. So this would be 91 out of 246. Which is 0.3699, or basically 0.37. So that's about 37% chance that that person is going to drive an SUV. What is the probability that a randomly selected employee is on the night shift? Okay, that's a different question. So, we need the total number of employees. Again, that's 246. And the total number of employees on the night shift. That would be 59. So this would be 59 out of 246. Which is about 23.98%. We're going to say about 24. So 24%. What is the probability a randomly selected employee drives a motorcycle and is on the morning shift? Okay, so we got to be careful here. So the first criteria was that he had to be a motorcycle driver, and it had to be in the morning shift. So morning shift, motorcycle, there's 4 people. And the total number of people, let's see, gotta be careful here. What is the probability a randomly selected employee drives a motorcycle and is on the morning shift? Okay, so we don't want the total number, we only want the people on the morning shift that ride a motorcycle. So there's going to be 4 out of, again, there's still 246 employees. So it's going to be 4 out of 246. Which is approximately 0.0163 or 1.63%. You got to be really careful about words on here, okay? And. All right, what is the probability that an employee drives a motorcycle and works the night shift? All right, so this time we're going to consider only night shift motorcycle riders. Okay, so that would be 5 out of 246 this time. 5 divided by 246 is about 0.0203, which is 2.03%. Moving on. Justin is doing a statistical analysis to check if sports cars in his town are involved in more accidents than other types of cars. He pulls 315 randomly selected parents of students at his high school and gets the results shown on the table below. All right, so had an accident, 50 were sports cars, 69 were sedans, 31 were SUVs, total of 150 accidents. Never had an accident, 55 sports cars, 45 sedans, 65 SUVs, total of 165 vehicles. And here's the totals. Now, does the table support Justin's theory that sports cars get into more accidents? Okay, so here's what we need to do. We're going to take the probability that a sports car has an accident out of the total number of sports cars. Okay, so sports cars, there's 50 out of 105 have had an accident. 50 out of 105. All right, so I divide that, 50 divided by 105, that's 47.6. So, if you're in a sports car, you have 47.6% chance of having an accident in this sample. Okay, sedans. 69 had an accident out of 114. 69 out of 114. That's 60.5%. Well, right there, that shows that more people in sedans had accidents than in sports cars. So you could say no right away. But let's do the SUVs too. All right, that's 31 out of 96. 31 divided by 96, 32.3%. Okay, so you're least likely to be in an accident in an SUV in this case. Then you would be most likely to have an accident in a sports car, and the most likely one is going to be the sedan. So the answer to this question is no. The data does not support this. Blank. Okay, this right here is called a Venn diagram. So in case you've never seen any of these before, okay, you have a group here. This group has a total of 57 plus 13, so it's got, 70 items in this group. This group over here has 30 plus 13, or 43. Things that are in this section right here are in both of these groups. There's 13 of those, and then there's 35 items that are outside of these two groups. So, Jennifer is judging a classic car show. She's also preparing a report on the cars in the show. There were 135 cars in this show. 70 of the cars had a manual transmission, 43 had air conditioning, 13 had both manual transmission and air conditioning, and 35 had neither. A car will be selected at random to appear on the cover of the report. What is the probability the car will have air conditioning but not a manual transmission? All right, so you got to find where is that section on the Venn diagram. And let's see, it's got to have air conditioning, so it's going to be in this circle, but it can't have a manual transmission, so it can't be these. So this is the cars that we're talking about. And how many of those are there? There's 30 of them. So there's 30 out of a total of, there was, 135 cars? So 30 divided by 135 is 0.2 repeating. So that's 22.2%. Chance of the car being a... Oh, wait a minute. Did I get that right? What is the probability the car will have air conditioning, but not, yes, not a manual transmission. So there's a 22.2% chance that it's falls in that category. The The following Venn diagram describes cars on the lot of Maselli's used car showroom. The letter B is used if the car exterior is black. T is used if the interior color is tan. What is the probability that a randomly selected car from Maselli's lot is not black? Okay, so that would be all the cars except for, let's see, the probability that the car is not black. So here's all the black cars right here. All right, so there's a total of 25 cars that are black. We want it to be not black. Okay, so we don't want the 25. Whoops. We want the rest of them. So how many total cars are there? Well, there's 17 plus 8 plus 39 plus 112 cars. So there's 176 total cars. We want to know how many are not black, so the easiest way to do that is just subtract the 25 that we know are black. And that leaves 151 cars that are not black. Okay, so the probability that the car is not black is going to be 151 out of a total of 176. That's about 85.8%. So there's a very good probability that if you pick a car at random, it won't be black. What is the probability that a randomly selected car is black, given it has a tan interior? Okay, so it's got to be both things. It's got to be black, and it has to have a tan interior. That is going to be those cars right there that are in that section. There are 8 of them out of a total of 176 cars. So 8 divided by 176 is about 0.045, which is 4.5%. That is black cars with a tan interior. There are 80 people who attend classes at Vitrone's driving school. The ratio of boys to girls is 2 to 3. So that means for every 2 boys, there's 3 girls. A student will be randomly selected to compete in a driver's safety contest. What is the probability that a girl is picked? Okay, so so if there's 2 girls, or there's 3 girls for every 2 boys, that means that there's 3 girls out of every 5 kids. So 3/5 of the girls, or 3/5 of the students are girls. That's 0.6, or 60% are girls. So we take 0.6 times the 80 kids, and that's going to be 48. Whoops, that's not what we want to do. It tells you there's 48 girls, but that's not what the question was. So it's going to be, it's just going to be 0.6, it's going to be 60%. Okay, now you're going to do pages 21 and 22 of your packet. They look like this. It says lesson 4.4 assignment at the top. Okay, I put better pictures of those on Google Classroom for you. So have at it, and we'll go from there.